The sole natural satellite of the Earth is the Moon. The only place mankind has ventured before Earth is on the Moon. It is the greatest and most gigantic satellite in relation to its home planet, bigger than any known dwarf planet. According to the geological definitions of the term, the Moon qualifies as a satellite planet, since it is an exoplanet object that developed into a distinct rocky body. Welcome back to another video of Fly Me to the Moon. In today's video, we're going to see how astronauts go to the Moon and how they leave from there. Before we start, please subscribe to the channel if you haven't already, and turn on the bell icon to receive notifications for upcoming videos. Now, let's get started. After the Sun, the Moon is the brightest object in the sky. The most noticeable result of gravitational interactions between the Earth and the Moon are the tides. Although the Moon lacks an atmosphere, there is evidence that many deep craters in its north and south poles may contain water ice. Regolith, which is a mixture of fine dust and stony debris created by a meteor impact, covers the majority of the Moon's surface. On the Moon, there are two different terrain kinds. One is the very old, deeply crater upland. The others are more recent, somewhat smooth craters that saw lava inundation. A continual stream of asteroids, meteoroids, and comets bombarded the Moon's surface since there isn't enough atmosphere to prevent collisions. This resulted in the formation of many craters. These collisions have broken up the Moon's surface over billions of years into pieces ranging in size from enormous boulders to powder. The lunar regolith, a mound of charcoal gray powdery dust and rocky debris, covers almost the whole Moon. The megaregolith is a zone of fracturing in the bedrock beneath. The highlands are the bright areas of the Moon. Impact basins that were filled with lava between 4.2 and 1.2 billion years ago make up the dark landforms known as maria, Latin for seas. Rocks of various ages and compositions are represented by these bright and dark patches. The Moon and other inner solar system's worlds' impact histories are provided by the craters themselves, which have been maintained for billions of years. On the Moon, you can find equipment, American flags, and even a camera that astronauts left behind if you look at the correct spots. The Moon, the largest and brightest object in our night sky, stabilizes the Earth's axial wobble, which results in a generally constant climate. This makes Earth a more livable planet. Additionally, it brings about tides, which produce a rhythm that has aided people for countless years. A body the size of Mars likely collided with Earth and created the Moon. The Moon on Earth is the sixth largest of the more than 200 moons that orbit planets in our solar system. In 1610, because Galileo Galilei's discovery of 4 moons orbiting Jupiter made some people aware of the existence of other moons, Earth's sole natural satellite is simply referred to as the Moon. We all know why astronauts go to the Moon, which is actually not a place fit for human life. They go there with utmost risk to study and research the Moon and check out whether there is any possibility for life in the future. We can first see how they end up on the Moon. On July 16, 1969, Commander Neil Armstrong, Commander Module Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin were still on Earth, 5 days before they set foot on the Moon. The Saturn V had 3 stages and was the most powerful rocket to ever take flight. When the fuel in each stage's engines runs out, the stage would extricate itself from the rocket. The subsequent stage's engines would then start, and the rocket would launch into space. The first stage was all about delivering power, with the tough goal of lifting the massive spacecraft off the ground. It was successful in lifting the astronauts to an altitude of 68 kilometers by exerting a force of 33 million newtons for around 2.5 minutes. The second stage began once the first stage broke apart. The astronauts were sent into Earth's orbit at a startling 28,000 kilometers per hour by the final stage, which burned for about 2.5 minutes. The third stage restarted for a further 6 minutes to launch Apollo 11 to the Moon, after doing a further 1.5 Earth orbits. The only thing left containing the astronauts was the Columbia Command Module. As a result, the difficult challenge for the astronauts was to dock with the Eagle Lunar Module in orbit and remove it from its cradle. Before reaching the Moon, the astronauts would have to wait a further 3 days. The astronauts ate, rested, and snapped pictures during this peaceful period. Apollo 11 fell into orbit after it arrived on the Moon. On its third round, Collins on Columbia observed Armstrong and Aldrin disembarking from Eagle and starting their ascent to the Moon. With the aid of a descent rocket engine, the Eagle lunar module was able to slow down, enter a low orbit, and eventually hover over the planet's surface. Armstrong guided Eagle semi-manually, utilizing 4 clusters of rockets and a landing radar, to finally touch down in the Sea of Tranquility on July 20, 1969. The lower portion in gold and black was the descent stage. In addition to the science and exploration tools, it had a ladder so the astronauts could take their first steps on the Moon. It also carried the rocket engine and fuel. The ascending stage was then expelled, remaining in space until an undetermined point on the Moon saw it crash. To begin Columbia's descent back to Earth, the astronauts first performed a deorbit burn. Then, they had detached from the rocket, leaving behind only the cone-shaped part where the astronauts were sitting. Seconds later, the heat shield flew off and the parachutes deployed. So now, have you ever thought about how the astronauts left the moon? Eagle's ascent stage was used by the astronauts to ascend from the moon's surface and rejoin Collins in the command module. Before they carried out the maneuvers that sent Columbia out of the final of its 30 lunar orbits and onto route back to Earth, they jettisoned Eagle. When they arrived back on Earth, they splashed into the Pacific Ocean. The Apollo 17 in 1972, the Challenger and Lunar's module ascent engine was turned on by the astronauts Gene Cernan and Harrison Schmitt, and they blasted it all out from the moon. Viewers around the world watched that same spaceship leave the moon live and in color on their television sets as these guys peered out the tiny triangle windows of the lunar module to see the lunar surface becoming farther away. The final moon mission's departure was, maybe not unexpectedly, significantly less exciting to the general public than Apollo 11's initial landing, which took place more than 3 years earlier. Even more evidence points to the possibility that NASA had to bribe television networks to even cover the Apollo 17 missions. The final human liftoff from the moon occurred despite all of their efforts and advancements in technology, but there was barely any coverage of it on the evening news. However, the scenario ignores the challenges faced by engineers in creating a way to depict the lunar module shooting back into space. In the late 1960s and early 1970s, television cameras were notoriously heavy and cumbersome, frequently requiring enormous rolling bases or portable stands. Any piece of equipment has to be portable and light in order to be used in space. Both RCA and Westinghouse were given contracts by NASA to construct television cameras for the Apollo missions, and both businesses were successful in producing units for various flights that complied with NASA's requirements for weight, materials, and functioning. Small, portable, colored television cameras were donated by RCA for the final 3 Apollo missions so that astronauts could be seen exiting the lunar module and landing on the moon. The cameras could then be transferred to a stand or the lunar rover for mobile exploration. The cameras were incredibly effective, recording pictures of a variety of EVAs, including sample collection, a view from the Mobility rover, and the difficulties of attempting to simply stand still in a spacesuit in 1/6 gravity. However, engineers had to perform a number of calculations before the mission to allow for filming during the lunar liftoff. A sizable high-gain antenna aboard the rover allowed the television camera, which was attached to a pan and tilt mechanism, to be operated from Earth. Mission engineers proposed pre-programming the lunar module's liftoffs for Apollo missions 15, 16, and 17. This was owing to the 240,000-mile distance between Earth and the spacecraft, causing signals to and from Earth to be delayed by a few seconds. According to mathematical equations, the rover would be driven and left some distance from the lunar module, and when instructed to do so by the operator on Earth, the camera would automatically tilt up to display the ascent. At least, that was the plan. With that, we come to the end of the video. Tell us your thoughts in the comment section below. If you enjoyed the video, don't forget to hit the thumbs up, subscribe, and tap the bell icon for more interesting content. Also, check out other videos on our channel. See you later.